Thank you. Yeah, so I'm an engineer. I don't know what to contribute to a room of business people, but I do have an application I do like to talk about, which is fire. So this works, right? So I focus in one of my projects is how to engineer the dynamics of fire. How do we actually dynamically obtain data during a fire? And the data retrieval during this emergency is an engineering nightmare. And part of it is because it's a very extreme environment. And the electronics in this doesn't work at certain temperatures. The robotics breaks down. Even if you have AI, it's going to break down. So what we're trying to figure out is how do we deploy non-human things, right, to capture data that we cannot go into. Right, and that becomes part of the challenges we have, not just on fire, but any disaster that we actually call on fire. Let me show you a video of an actual house on fire. I've noticed things when I see a video like this, because there's things that are happening and things that are not happening, right? And in the US, this is like about 3 to 4 fire trucks attending to this emergency. None of these people are going inside. None of them. Obviously, there's severe reasons for it, right? But there's no information from the people who were trained to attend to this fire to do something about this, right? So what can we do to make sure they know what's inside, right? What do we need to know for them to actually act upon this? But why is no one going inside, right? And there's ways that we can actually engineer something to make this work. Now, material scientists will kill me because they'll tell me we don't have material that handles 2,000 degrees, right? But there is. We've done it for the NASA shuttle for re-entry to the atmosphere. That's actually material we've actually engineered. So it's actually possible and doable to do something. We are looking into robotics, we are looking into AI, we are looking into even the politics of trying to implement this because it's a nightmare. And in the US, there's a lot of regulations, there's a lot of things that we have to consider to make this whole thing work, especially in the financial part of this. Because as an engineering room full of business folks, we're the pesky people who keep asking for money. Right? We're the ones who need more because we keep breaking, we keep rebuilding, we keep generating, right? So in a sense, the hypothesis is very simple. On the left, we wish the house on fire tells you and gives you data to the first fire responders. The problem, even if you put smart sensors on a house or a building in downtown Austin, even if you put it and load it with a lot of sensors, if the building's on fire, the sensors are on fire. So what was the point, right? So we need to deploy the solution in order to get the data, right? Simple diagrams to solve a simple solution in the worst case scenario, right? The problem here is that now we have to manage robotics going in and things flying. Well, who owns air in the United States? The FAA. The FAA owns anything above this carpet all the way to the atmosphere. Anything above the United States, they own it, right? So can they just deploy without telling the FAA what they're doing, right? So that's another logistical nightmare we have to deal with. Things that we've done is that we're looking at rovers. We've designed our own rovers in our building. We're doing our own drones. We're looking at a digital augmented reality twin of us controlling a rover, looking at what the rover's looking at through real-time camera. We can see real-time data, and we're using the HoloLens, the Microsoft HoloLens, to actually see this in real time. Right, so a senior design team designed this, and we're working towards, right, you can see how it's moving everything, you can see how it's moving the rover, just by touching things in the air, right? So he's working in building a digital twin to real-time see and provide that kind of technology to firefighters, really. This is the evolution of what we've done in the last 4 years with the rover, right? We started very small with simple concepts back in 2020. Undergrads were mainly the ones in charge. Then by 2022, we've developed something a little bit more complex, a little bit taller, a little bit more capable and robust to handle things like obstacles, like simple things on the floor. And then we started building them higher, bigger tires, bigger capacity in order to go upstairs, right? Because buildings have multiple floors we have to engineer, right? So that kind of helps, and then we still keep evolving this over and over. Problem with this is that even if we go into a burning building, it's going to melt at the door, right? It's a prototype, right? It's not meant to withstand that kind of high temperature environments at this point. But we're building in the complexity, the programming, the hardware, the AI that we're actually building on. So a couple of drones that we're using, they're equipped with cameras, they're equipped with LiDAR, they're equipped with so many things that also fit into AI models, right? Because we want to detect, if you want a drone going to the 5th floor of the Google building, somebody's stuck, you should be able to detect that person and then tell the firefighters where that person is, right? The goal is that you have help in an immediate sense that helps you localize people immediately, right? A search and rescue optimization, right? One of my grad students is working with reinforcement, and you can see the agents optimizing how we're going to let AI move the rovers for us, right? Because the last thing we want is firefighters to control these manually. Firefighters, one, they're not engineers. Two, they're trained to do other things. Therefore, our robots need to manage themselves. So we're teaching them how to optimize their battery because they're battery powered. There's a limitation to this, right? How to best optimize and do exactly what a firefighter would do going into a floor, right? So first of all, they don't understand the environment, but the goal here, go into every room the way a human would, right? They need to imitate what firefighters have been trained to do. If we keep evolving these simulations of the AI agents, we can then have these self-deployed, self-efficient into these things. I guess it's a different thing because I could have loaded you with the equations, but I like pictures better, right?
Thank you.
Well, people are just smarter than me. I don't know. Either way, I'll take it. So the goal here is that we have robots going in, and in the middle, we're doing environmental data analysis because you kind of need to know at what time of the fire you're in. Are you at the tail end of the fire, or are you at the beginning where it's starting to peak? That kind of matters because if you send firefighters at the peak, we've seen examples of their mask melting in front of their face. That's not a good place to be, right? And so you want to be able to understand the situation once you get in there, and I'll show you a video what happens when you don't, right? So you have detection, we have AI models that detect screaming, right? Because the camera doesn't see everything. If you're screaming behind the rover, you still want the rover to hear you, right? And then we triangulate the position with vectors, and we do all this math in the computer, and then it triangulates, and then we can move the rover to that direction, right? And so we need infrared because infrared frequencies, when it comes to computer vision, you can see there's smoke, right? We have limitations of that, but infrared frequency cameras can actually help us see through that hazardous environments. Thermal obviously will give you that kind of feedback as well. LiDAR depth cameras are very much used like Tesla cars, right? They help you navigate obstacles and recognize what's your environment around the navigation aspect. The whole goal as we keep equipping these things with technologies that we send all this information back to the truck. Let the humans who were trained to see these scenarios act upon that decision, right? AI is not telling them what to do. AI is informing them what's going on, right? And so we still need the human in the loop to make sure that this actually works, right? when we're talking to smart anything, we need to invest, right? So if we're gonna smart firefight this thing, we need investments. Startups, research, big industries can obviously help to fund these type of resources we need. It's a very difficult thing, right? But the ideas need to come because we need new ways to better make the investment more of a return of investment to everybody who's in that emergency, especially if it's your house on fire. And we'll get to that question soon, right? But we need to figure out the material. We need to figure out the technology, the software, there's the AI capacity. What kind of computers can withstand that kind of temperature? What kind of programming, besides NASA's team, can we actually make it more efficient? Can we find new support for this? Firefighters are also trained to handle a scenario like in that picture. It's not just house residents or the nice guys on I-35 looking at a vehicle accident. They also need to handle this. They're trained, they're supposed to go in there and handle the situation. How? I don't know, right? But wildfires are a very common issue in Texas, even though we don't hear from them a lot. Last year alone, in the state of Texas, we had over 500 wildfires, and it was nowhere in the news. Over 500 wildfires in Texas last year, and we didn't have enough firefighters in the state to handle it, right? It's a resource issue that we have, and we have to deal with any chemical, industrial, oil rigs in the sea, in the middle of the ocean. These guys have to go in there and deal with that. Trust me, I have a great job. I'm not going to I don't want to do this ever, right? These are the questions we're trying to answer. As I'm engineering this project, who builds them? Well, I want to be that person. I'm trained as an engineer. I want to be the one building the solutions. Who deploys them? Well, that's the government thing. And even if I get investors and private investors, they don't necessarily need to be the ones deploying. Who maintains them? That's another issue. Everything that we build, that we generate, that we develop, somebody needs to take care of it. So I can have the perfect solution, but if it's a one and done, it's useless. If it's only working 10 times, it's useless, right? We need to be able to maintain these things because they will go into extreme environments. Therefore, we need to have a way to keep them operational, right? Otherwise, we've done the engineering incorrectly. I did some numbers since 2020, what I've spent in a sense of the stages in where some of my grants, contracts, and everything has been going, right? I'm way beyond this number at this point, right? Mainly because everything we've done in the lab has been old prototypes, and we've broken a lot of things. So my students love the fact that we get to play with toys and break them. They love that part. Why? Because they know I have some kind of financial support behind it. We can be kind of aggressive with it. At the same time, I also tell them I'm not made out of money because I do have a limit on this. But these are kind of some of the low-end expectations of just building prototypes of these kind of things, right? In America, first responders are budgeted through counties. In America, right? Counties have to make decisions on their limited budgets. And that kind of limitation of budgets has to deal with first responders of any kind. That includes medical, fire, policing, and anything that we use, right? And part of their policies is, will the question be, will it help us improve any innovation that we do with first responders? Right? What is the public benefit of us, the county, purchasing technology like this? What is the return on investment for a county to improve in something like that? Can the images of rovers and drones, when they go into an emergency and record everything, are we going to treat that as body cams? Are you going to let your personal house, as it's on fire, as people are being recorded and things are being recorded, are you going to be okay? for to be public data. I'm introducing that. I'm aware of what I'm introducing as I'm developing the technology. Why? Because will an insurance company would like to see that? Yeah, they want to. And then just once they want to keep it forever, right? And so insurance companies will eat this up. So who's going to protect you? Who's going to protect your data of your house being recorded on fire? Especially when you have those nice collections of things you do in NYC. Let me show you what happened in Buffalo, New York. This is what happens when you don't have data going into an emergency. The building exploded right in front of their face. And on the side view, you can see you see the immersed energy that comes out of that. This is what happens when you have no data. This is what happens when you go into an emergency, you have no knowledge. They're trained professionals. This was made a decision by somebody with 20 plus more years of experience, and they still failed. AI can provide solutions to this. We can avoid this, especially for insurance that deal with that. Hong Kong. Look at that story building. Where's the fire at? It's not in the basement. What are you going to do if you live in that top floor? Who's going to come at you and help you? Because when you're during the fire, you're not using elevators. So where are you getting the data information from, and what kind of opportunities you're missing because all they're doing is looking at the building? What else can a firefighter do? Just get the people outside, make sure nobody's around the building, but they're not going to run 80 floors up, right? These are issues that we have to do. Just watching is not a solution. It shouldn't be, right? So how fast can you get up there? How can you prevent stuff like this? So I asked Dali, how does the future firefighting look like? I love these because I felt like I asked a 5-year-old to draw me this. And so I love them because we actually have a firefighter fighting one of its own technologies. So I'm talking about hallucinations. This is really hallucination right here. So maybe very comfortable with this picture and some of those things, right? But these are very interesting portraits of what we think this is going to look like. So I always like to say, what did I do? How did I do it? And why are we doing this? Well, what am I doing? I'm dealing with fire. We're playing with fire. We're solving fire. We're engineering around fire. We're trying to figure out the area around fire in order to search and rescue people out of the fire. Everything has to do with fire. The problem is, it's fire, right? Why do we do it? Well, we showed you videos. I showed you some videos of what happens when you don't have that information. That information can save lives. It can save the lives of the responders, save insurance companies a lot of money, right? And then we can invest in a more efficient way in dealing with emergencies, right? How do we want to do this? Takes money, right? Finance will actually be the ones helping us. So firefighters are not, maybe they're the ones not deploying the technology. Once they get to the fire, maybe they're not the ones doing this. Maybe it's a different service that needs to come in with them and deploy that. Maybe it's a team of Geek Squad and engineers like me to go there and deploy them and then get them back and then maintain them. That could be an extra service, right? We call that workforce development, right? And we create more jobs out of it. Anyways, I kept it short because it's lunch and I think I got it on time. So, any questions? Oh, wow. Yeah. I saw your hand. No? Okay. I saw your hand.
Yeah, I had a question about the kind of the difficulties of the reinforcement learning, like training an agent to handle an environment that is probably going to be changing actively, since it's such an extreme environment. I mean, I can imagine, I guess the LiDAR is pretty important with that whole. Do you foresee a rover having a lot of difficulties with, say, a roof collapse or a floor collapse or something like that? Like the environment is changing so much that I can see difficulty with the reinforcement on the agent figuring out.
Yes, so we have developed models to forecast the situation.
Okay.
Right, and that also is to prevent that the rover is actually stuck in a bad area. And that if the robot is the first thing noticing that, it will prevent humans going into it. So the worst case scenario, you lose a robot, right? But at least you know the situation, you don't send humans in.
Right.
Right, so we're designing the knowledge of these things based on worst case scenarios as best as we can. Right, and it's tricky because optimizing this will take a while to be as effective as possible. Figure something more. Yes.
Yeah, so I had a question. So how would you use the robots to sort of detect, like, because there's different types of fires, or there's like natural fires, and there's like chemical fires, grease fires. So like how would you use that sort of technology to detect like what type of fire how it started, so you can better assess the situation?
Well, assessment would be the way we do some. Right, if you want better assessment, then the robots need to assess. Right, so that means we have to also train them to not just go into a burning house. They need to be trained to different modes of, is it oil rigs, is it industrial, is it a wildfire? They go into different calls, right? 3 out of 4 calls the firefighters attend to are vehicle accidents. That's the whole day, every day. That's the average. 3 out of 4 calls are just people, not knowing how to drive. That's basically how it is, right? So we need to keep adapting the capabilities in a way to assess situations first. That's going to take a lot of computer vision, a lot of reinforcement training. Yeah. Yes.
Yeah, Daniel, I know this is not just the only thing you do. Can you talk a little bit more about how you are doing data work or how it's within education, other applications?
Right, I use AI for other projects I have. Emotional recognition to help children with autism is another one. We're using the same rover idea to monitor behavior and health of cattle for agriculture people. Anything the robot can do, they're trying to make me do it. Today, I don't know yet, but I am trying to figure out different applications to go to different spaces. Yes.
Excellent, President. Interesting. Like, I mean, you're using like rovers and stuff like that. Is there any? I mean, it's clear to me that there may be some demand for like improved edge devices, which are maybe baked into buildings. And is there a case for, sort of working that side of it rather than building regulation, particularly for the higher story, high density buildings?
Yes. So there is an effort by every state in the United States to advance air mobility projects in where drones are called into different actions. Part of it is the emergency services, and the state of Texas with TxDOT are trying to figure that out as far as the policy goes. How is that going to look? At the edge, companies are building more CPUs within the cameras, within the sensors that become smarter. We just have to figure out how to protect the electronics from the high temperature.
No, I was going to say, like embedding it in the building, in the concrete, in this, that, the other temperature.
Well, we
I don't know how much.
could put them in the walls, but if the walls are on fire, they're going to be used. Right.
Yeah, some improvement.
Everywhere. Right.
I was thinking about deployment, like these technologies tend to be deployed in stages based on when they become commercially viable.
Yeah.
If you were to envision how you see or where you see them first being deployed, whether it's wildfires or probably not on fires, buildings and other things.
Right. So firefighters train in controlled environments. They have facilities where they can light up any structures, and they can go in and train. So that would be once we're ready for an actual fire. That's the first logical step. Actually partner with the fire department, let us go in there and then provide testing days where we can actually go in and do that. And then from when we do actual testing outside of our research lab, we keep learning how our software's working, how the AI is working or not working, right? And then we go and then we do revisions and so on. But the next stages would be to work with the fire department so they can see the technology, because we don't want them to feel that we're trying to replace them. We're trying to enhance their job, right? Which is an understanding that community doesn't have. So part of this effort is also communication to the community, right? Because I don't need them to feel threatened about the technology. So that's a challenge.
So I got a question. I mean, the entire goal of this is to try and avoid going into a building. The reason why you're going into a building is to save lives, right?
Sometimes.
Hopefully the number one priority.
That's why, right? So the good news is that somebody may not be.
So the number one priority I would hope would be to save lives. And hopefully you're, in most cases, you would not want to go into it if it's unoccupied. Saving would be massive industrial accident or high rises and all the rest of this. We have these things all over the place. These things can go into houses and make the signal and all the rest of it. We have the ability to blast out messages about some random dude at Texas State, whatever.
Correct.
We know who lives at those places. So why wouldn't we just sit there and link that up? And try and see where those guys are at. Find out where these things are at.
Right, so access to that kind of data is not open for everyone.
But, right,
And so that would be a policy issue that needs to be straightened out in order for us to go for something.
but we already have those emergency channels.
Right, and so, but I don't have access to that. I mean, I'm no one for them to grant me such things, right?
Right.
And so, even if they know you're inside or you know exactly where you are, somebody said circumstances change during the emergency, right? And so if this changed during the emergency, then we need to be equipped for those changes, right?
But I'm thinking there's other ways that we can use the fact that, I mean, there's no reason to send any, I'm thinking there's ways we can use just other remote sensing frequencies and all the rest of that stuff.
Oh, right,
Can we strap something on?
right, the communication, we're working on that design as well. We're using radio, Wi-Fi, depending on the type of data. We're encrypting the data. We don't want anybody to just capture the data, right? So there's other layers to this that I didn't go over, but the complexity of the engineering approach is what keeps me awake, really, because it's a very complicated multi-angle issue that I'm dealing with. And investors and funding agencies have been gracious enough to provide that support because they see the necessity of such technology to actually evolve. But I agree with you, there's many things to explore, and cell phones just one way during the emergency and reactions of people in that emergency.
And Dr. Jeff Todd is going to talk this afternoon about legalities.
Yeah, okay, so let's end it here. Thank you.
Okay.
And we also expect this app to provide individuals with AI-based kind of financial assistance and personalized guidance and advice to help people understand the importance